very good morning. It's wonderful to see so many people here. This is a fantastic auditorium. I know how deep it is because I could see before the lights. But yeah, wonderful. Thank you for everyone who's taken their time to volunteer for these events. Huge fan and proponent of the community. A lot of what I learned as an individual before even starting a company or getting into some of the more difficult regulated spaces was just learning from other people in the community. So huge thanks to the maintainers, I know, and the organizers, maintainers in many ways. It's a huge amount of effort and very deeply appreciated. So, hi, I'm Andy, founder and CEO at ControlPlane. We are a cloud-native cybersecurity services business, which has meant taking banks onto cloud, containers, cloud native, and now, of course, AI everywhere. All still the same stack, often still the same problems. But today I want to talk about the emergent issues that AI has brought us, not only from a sort of wider attack and defend perspective, but also open source maintainers. How are they dealing with this? And I know this is a conversation that we will repeat throughout the day. We'll just try and remove that bar again because it's very frustrating. All right, I know how to do it now. There we go. How have I just lost the window? I'm so sorry. There we go. I am a long-term Linux on the desktop user, which is a kind of self-enforced pain that somehow managed to replicate onto here. There we go. Ish. How is that broken? Well, this is very interesting, isn't it? Let's one more time. Well, that's remarkable. Right, there we go. I think finally, there we go. Right, there. Andy, hello, etc. Introduction. Right, open source. What is the deal with open source? It is the world's greatest meritocracy. You take code, you put it out on the internet for free for anybody to consume, and by virtue of social proofing, which ultimately is kind of GitHub stars, give or take the collusion and botnets that you can buy stars from now. And that gives us this meritocratic view where good code, quality maintainership bubbles to the top. And that's why everyone's been using open source. 10, 15 years ago, regulated industries had the Mexican Spider-Man standoff effect. Who's going to move first? And then the deluge, everyone's using open source because, of course, reduces cost, transferable skills. We don't have to re-implement the same thing every time. And we have the thousands or the many eyes concept from the Linux kernel itself. Many eyes make bugs shallow. Does this contract still hold up in the age of mythos? We ask ourselves. Right, code, there's various different types. First, third party. What we'll talk about today, the first party code is what we generate or what our organizations generate. Then we have our third party code, which is ultimately dependencies. And then there exists code, which has been in production for a day, week, month, year. A recent study suggests that in regulated industries, only 7% of deployed code is using the latest version of its dependencies. Quelle surprise. We're not surprised. But what does that mean for automated attack? And languishing and unloved. Of course, Lib Nebraska actually came true when it was discovered that there are many maintainers living in Nebraska. And these stats on Slopsquatting from this paper, 19.787, etc. I made that up, obviously. I did verify these numbers, incidentally. It's reasonably harrowing. The rate at which token maxing and therefore this AI slop can be constrained into something useful is terrifying. The concept of how an LLM works in the first place, everything is a hallucination. You give it a bounded context, and it will hallucinate freely. If you can control that hallucination, you might get code that you can statically analyze. You can put tool calls in, you can actually get it to a straight line. But everything's a hallucination. It just depends what context you bounded it with. So this is a fundamental inbuilt problem. And slopsquatting is the process of an LLM generating a version or a name of a package that doesn't actually exist. It would like it to exist. It would be useful if it existed. And the first person that sees that and thinks maliciously then goes and registers that, puts code that looks like it should be there. Then that's an attacker-controlled repository. They can push a malicious update. That update gets potentially, speculatively, automatically built in your CI. Hopefully it doesn't make it to production. We have seen this go wild this year, and we'll look at a little bit of this as well. And the other side of that equation, of course, is AI automated or assisted attack velocity is also at evidently an all-time high. Hopefully a high watermark, probably not. But again, we'll talk a little bit about Mythos and what that means for open source and for security. So we're at a critical crossroads. All this open source code, if we're running on the latest versions, is generally secure. We see the curl maintainers say, I had Mythos access and it gave me one bug that was valid. We saw Cloudflare say, we had Mythos access and it gave us 50,000 bugs that were mostly actually very low confidence and not verifiable. But then we built a harness, and the harness constrained the execution space, iterated in a more constrained way than the model sort of generally doing everything. And they had huge efficacy, found it very effective. My customers who've been in Glasswing say DeepSeek 4 Pro with a harness was Mythos level months ago. So there was some very good marketing. It is a real issue because Mythos has the ability to chain very low severity CVEs. It's basically a very good CTF player. And that's not awful if we're on the latest patch versions. Many organizations are not. And that's actually the problem. So what does this mean? This crossroads for open source. Some people are suggesting now is the time to close source everything. Let's turn the key, shut the door, and that which cannot be seen, security by obscurity, is more secure. We know that that's not true. Very good CTF players are good at things like blind injection. You don't know the memory space that you're injecting into, or whether your untrusted code will end up as part of a SQL injection or an XSS. It's all about running latent code in the wrong context. Untrusted user input, etc. We've trained these models on the corpus of human information. Humans are pattern matchers. We have different streams and signals coming in, and consciousness in some way arises from how we match patterns across those things. We can always hear our name in a busy, loud room. The brain is wired to its own name. And it's the same for LLMs, but they're just orders of magnitude better. You can talk emoji binary to an LLM, and it'll get through a prompt firewall, be decoded, and then you have a prompt injection from emoji, because it's always looking to find these patterns. So we can't close source or remove things and hope that that's suddenly going to make us secure. The threat model is different. We're dealing with a different style of attacker. So there's a suggestion from the US. There's this executive order from last week. There's some clearinghouses opening for open source. The same conversation happened at FOSDEM this year. Do we just fork open source? Because we can't trust the maintainers, the geopolitics, whatever it would be. And in this case, IBM have said, big shiny number, 5 billion. I mean, we'll see the receipts. But IBM have a history of patching things, hiring maintainers, and pushing back upstream. So this is probably okay, as long as we get the patches, because otherwise we're forking open source, we're in a walled garden, and ultimately we risk the fundamentals of community and open source contribution itself. So, excuse me, you hear a little bit of rustling. There we go. That's better. Okay, so open source AI attacks. Oops, one too many. As we know from, There we go. As we know from the SolarWinds debacle a few years ago, where Russia was able to get into a build chain and insert code between the compiler step and the packaging step. So the source code that went in looked correct. The binary that came out was signed, but there was an insertion in the middle. That implant was deployed in DoD and Microsoft and all sorts of US government places. And that caused great soul searching across the industry. And so we had the supply chain attestation levels in SALSA come out as a response to this. And this classifies build attacks and the provenance of a build system in simple-ish terms. If we overlay sort of some of the attacks and AI onto this, then at the source, you can attack maintainers. You can sock puppet them, what we happened with the XZ attack, where you essentially file fake issues, put pressure on the maintainer. They handed over the keys to an attacker who then pushed some code. Unfortunately, that was found by a Microsoft researcher who was concerned that SSH was taking a little bit longer to connect. And the thread was pulled and it was discovered that the attack had come through by socially manipulating the maintainer in the first place. Then you've got the commits themselves. One of the control plane sponsors the Flux CD project. There are dark web bounties on the GPG keys of those maintainers. I mean, again, not entirely surprising, but access to those keys give trust, and obviously there's other things you need to get in to do the commits. But again, from the source perspective, that's where we're in trouble. And of course, the accounts, NPM, if you're an NPM package publishing person, you'll know that the 2FA story has been awful. It's taken them years of semi-advisory, please, if you don't mind, mandatory. Why would we not have 2FA on everything? Especially the source of distribution into the entire open source ecosystem. Build, attacking the pipelines, it's the SolarWinds style attack. Caches, we've seen poisoning of GitHub Actions caches plenty of times. The answer to much of this is just pin your GitHub Actions. Not all of it, but a lot of this is kind of boring build stuff. And secrets, leaking those secrets, reusing keys. Talking to the Trufflehog founder this week, he said you'd be surprised at the amount of SSH keys which share the private key with a public TLS certificate. I said, what? He said, yeah, the certificate transparency log and all the public keys on GitHub, some of them correlate, and somebody's just reused the same raw key material for identity and public key. Wildness. Very interesting, incidentally, the Trufflehog team basically do internet-wide private key scanning for thousands of different types, and have an insane data lake. So distribution, registries, well, this is the fundamental problem. If I built something, but someone else pushed something. So there's no link or trust between what is built in CI and what's distributed, unless we get into SigStore and Cosine and then Toto and whiz through those, validating those when they actually turn up, and the consumption there, we're now at a threat model where the AI sandbox is a trust boundary for us. Whatever's going on in Cursor or your Claude code, that's the source of danger as well as innovation, and then runtime behavior, of course. So some of the attacks, whoops, one too many. We've seen XZ, social engineering of an unpaid maintainer. Classic. Security debt is not being paid down, and this is where Mythos is now causing all this consternation. Event stream, if you remember, back in the day as these things were really getting going, CNCF, again, sort of NPM level. Same with the sort of BNC, these are linked through to the SALSA. And then, of course, log4shell, which was actually the inverse. There was no malicious attack. It was an oversight with interpolation into logs. But the industry response was suddenly, we must patch everything immediately. And as we'll see, there are other remediations that you can play here. If the code running log4shell doesn't need outbound internet access, close down the network namespace, apply mitigation firewall control somewhere else, and run vulnerable code in production. Because if your security team will sign off on that, and you're able to use automated evidence, which we'll talk about in a moment as well, you saved yourself toil. Developers need to ship features. That's the point of business in many ways. So many of these attacks that just send up the flare, give the board a collective heart attack, can be dealt with in other ways. But what's happened recently? Well, in March, we saw what is now the MySpace worm of modern open source development. Again, the truffle hog was used in some of these attacks, and it was specifically looking for NPM, publishing keys, and something else that I forget. If it had looked for the other selection of keys that truffle hog finds and used those too, think of the extrapolation. It would have been significantly worse. And we think they didn't do it because of an oversight, potentially. There may also have been, it's a lot noisier if you go for everything at once, but imagine trying to shut down every piece of key material that you have on your local machine. That is, of course, any SSH or GPG keys. It is the OAuth tokens that sit on disk. Once you've authorized, you've got 8 hours that can just be reused. Your publishing keys, third-party, for pushing things up to third-party recall, append-only logs and that kind of thing. So it could be reasonably catastrophic, and we haven't seen the worst of this because these are still vibe-coded, early-stage attacks, essentially. So these chained on top of each other. Team PCP doing a lot of heavy lifting here. We have also seen these threat actor groups start to collude and draw together because the level of access that they popped, hundreds of thousands of credentials over this month. And so they farm them off and they sell them to each other, and detection of our internal estate is key because undoubtedly everyone has been exposed to something or other here. And as I said, the answer in many cases is pin the damn actions that we're using, and that clears a whole class of attacks where people are republishing GitHub actions that everyone's using. If we're checking out of version 4 and there's no pin by content address or hash, somebody deletes those tags, pushes the vulnerable version that exfiltrates the build secrets, and everybody who runs the next build, or if you build on dependency change, suddenly triggers across GitHub. And they trigger over 24 hours for very big dependency updates. But if you're not pinned, you're vulnerable to this entire class of attack, and it will continue because, again, we're paying down security debt as an industry. So April, end of Q1, we get to 75 of all attacks are on NPM, total of 1.3 million malicious packages detected by Sonatype, and a lot of this is the packaging to publishing step abuse. So it's not attacking the source code, it's attacking the step that pushes that into NPM or into PyPI or into Maven or Docker Hub, etc. May and June, we had Miasma again, which is a shy halludes, which again, these worms look for keys in exploited systems and then republish themselves, and off they go. And it's an exponentially increasing attack. There are very simple ways to prevent this. Your cooldown time on installing third-party packages is supported by some open source sort of interpreted language tooling. For an enterprise, this is having internal Artifactory, Nexus. The code goes in there, and you don't allow it into the organization for 6 days. The cooldown period enforced in some manner. Very simple ways of not being on the edge for these attacks. So yeah, the trend here, artifact is not source. We have no build correlation. We haven't really thought about this in open source for a long time. This, of course, is where Sigstore, cosign, all that good stuff comes in, because we keep on signing artifacts and evidence and attestations that can then be verified at deployment time or ingestion time in order to be sure that what we're deploying is what the maintainer thinks we should be deploying and not an interstitial implant. Name resolution is fuzzy. Typos that we make as we type in package names, people have often squatted those beforehand. That was a historical problem with AI. It's just gone 10x because we don't do dependency resolution visually. We expect the registry to do it for us. All AI agents are poisoned. The internet is a dark and dirty place, and it's the training data for all AI. So if you look at the new, the Mythos and I forget what they've called, the Fable releases, system prompt, jailbroken within minutes. And if you read the way they self-identify for security, they've jailbroken these models. There's no way to convince an AI that it shouldn't do something when it's trained on humans and we're inherently fallible and prone to specious reasoning and misdirection. The registry worms we've spoken about are really just speeding up very quickly and will continue to do so. And inert data is now prompt injectable. That means that we have that there's a risk of non-printable ASCII characters in README files and in GitHub issues injecting into our coding agents. Wild. I have a suggested solution for that towards the end. So 2026, how do we secure open source? It is quite basic. We've known this for many years. It is boring. It's not that much. It's not glitzy, but it's all pipeline based. We've now got a rapid CVE remediation step that we have to do because CVE is happening so quickly. Many of them are not even announced. Project Zero set 90 days for CVE remediation. Glasswing is setting 30 days. Realistically, this has to be 24 hours or less. So there are tools from the OpenSSF and CNCF to help us here. I'm sure we've seen many of them before, but the integrity of the Git repo is the first thing. We need to make sure that it's configured, no pushes, no speculative builds, and that we know who is in that maintainer group. Attestation means for every action that's taken, the inputs are hashed, the transforms are observed, and the outputs are signed by the person who liked the thing at the time sufficiently to give it a signature. So it's just a link to the person who owns the second factor, the GPG key or the Uber key. Also, robot accounts will do this. This gives us trust in those individual build stages. We revalidate that and trust anchoring of SigStore, and then we check for dependencies, and at runtime, we validate policy. Sounds easy. Again, this is very much sort of classic DevSecOps and cloud native as we know and love. Yes, we did know it already. And this is security debt, and this is what Mythos has exposed. It's very easy to save money, to think about the shareholder value of not doing something when there's no direct repercussion. The direct repercussion now is chaining together these low severity CVEs or vulnerabilities at machine speed with no machine speed defense. Yeah, there we are, why the urgency has changed. This is from some of our internal decks. A manual response does not scale. This has to be automated because nation states have access to Mythos level tooling and have done, and that's why we're seeing so many fast supply chain attacks. The DoD told us all about how they do this 6 or 7 years ago. It's a software factory. It's not beyond the wit of all of us here. Yes, and resilience demands this patch hygiene and the speed of remediation. And this is where we have an open source splinter risk, because if we do not move quickly and move collaboratively as a community, this code will go behind walled gardens where people are selling it into regulated industries and governments and critical national infrastructure. And we're back to fund your open source maintainer, give people access to open source models. We will have Mythos level models for everybody within the next 3 to 6 months. As I say, with the right harness, it's already there. Some of the other models, and end-to-end artifact visibility. Where's this come from? What are we doing with it? And how are we enforcing automated policy as code, machine-readable governance? Again, not beyond the wit, but there is a lot there, and there are standardized patterns for this. Unfortunately, attackers think in graphs and defenders think in lists. We have to check off everything on these lists to actually keep ourselves secure, whereas the attackers can pivot wildly through a problem space until they find one thing that's been missed. So, just keep ticking on to the end. This is the way that we do it in an automated manner. And the important thing here is the agentic remediation harness that we will all have to apply. Whether or not we like this, the Open Bow project, for example, can't accept AI-generated patches because somebody wants to put a pull request in with a HashiCorp license at the top, which would be slightly litigious, baiting. Whereas Flux is fully agentic remediation with a human in the loop to say that's completely the wrong philosophy of how you patch this, let's do it this way instead. But we have to have the same tooling as we're being attacked with, and this is, on the one hand, bumping dependency versions, that's not particularly complex. On the other hand, if there's fundamental flaws in first-party code, how quickly can we have those surfaced? And a machine-readable foundation so we can provide information to our auditor. This is the OpenClaw imagery of choice. Unsecured models are a trusted, non-deterministic, potentially hostile, wildcard threat actor behind your firewall. This is what I mean. Everything is a hallucination, and it's very easy to misdirect these models. Claude taught itself to escape its own sandbox, so we put extra sandboxes around these things. There is a fantastic tool called No from a friend of Control Plane, Luke Hines, creator of Sigstore. This is a user space sandbox. It's bubble wrap on Linux. It is seatbelt on OS X. It's pretty damn sweet. It works in a container, works outside, works in a VM. It's kernel space limiting from user space. So what do? You set that up. You run this probe inside, which is enumerating the entire file system network, looking for mounted sockets, looking for GPG keys or any credentials that you've accidentally left in there. And this gives us an iterative loop to protect our local coding agent, to protect our pipeline remediation agent, etc. And importantly, throughout all of this, we must continue to fund humans. We're here because of community and voluntary work from organizers and sponsors, but fundamentally, things don't get done unless money flows. And for CISOs, they should be sponsoring the top 3 projects. For CTOs, they should be putting money into the pockets of open source maintainers so they can purchase access to new tooling or the GPUs they need to run an open source local model. Fundamentally, we can continue with the open source contract as long as we start to pay down maintainer and security debt across the industry. Unpopular to tell a bank or a consumer that's got away with this for free, but they're about to spend a lot of money on closed source, open source, so the money is available, and I appeal to their better sense of humanity. So, in order to understand what we're doing, we can classify attacks by where they come into SALSA. The new trust boundary is that sandbox for our AI systems. Pipeline trust underpins everything. With full end-to-end trust of the pipeline, plug in as much AI as you like, and you have auditability and back traceability. Threat model, everything, and self-serve governance and trust. And with that, have the most wonderful day. I will talk to you all later.
Any questions?